Hello, good afternoon. I hope you can hear me. We are waiting till people can join. This is kind of informal start before the next session. It's my great pleasure to welcome you here at this joint part with the Aerogel Industry Academia Forum and also at our first edition of Aerogel Architecture Award.
Gut, mein Beitrag ist, die deutschsprachigen Zuhörer auf YouTube, auf Zoom den Forumteilnehmer und die Personen hier in der Halle des Nest Experimentalgebäudes in der Empa zu begrüßen.
My name is Michal Ganobjak and my colleague Samuel Brunner will translate into German. I would like to welcome people here at Nest and also who joined us online. Note that from now we are going being recorded and it's streamed on YouTube.
Ja, von nun an wird es aufgezeichnet auf YouTube und die Einführung machte der Hauptorganisator Michal Ganobjak. Mein Name ist Samuel Brunner. Ich bin an der Empa als wissenschaftlicher Mitarbeiter, technischer Spezialist tätig.
Video will be published also online later, and but if you will have any question, you can forward it to our email aerogelarchitectureaward@gmail.com.
Ja, bei Fragen können Sie sich zum einen an die E-Mail-Adresse auf der Webpage wenden von Michal Ganobjak oder an die E-Mail-Adresse aerogelarchitectureaward@gmail.com.
Here at Empa, at a Laboratory of Building Energy Materials and Components, we focus on a building application of aerogel materials. Specifically for buildings are interesting thermal insulating properties, acoustic properties, breathability, translucency. And
wir sind von Empa, im Speziellen von dem einen Labor für Materialien im Bau und energiebezogenen Bauanwendungen und deren Komponenten. Es geht um neue Anwendungen zu entwickeln, bestehende weiterzuentwickeln. Das Spezifische an diesen Aerogel-basierten Produkten ist meist die hohe Wärmedämmfähigkeit, der niedrige Wärmeleitfähigkeitswert, Lambda, die Dampfdurchlässigkeit, in Englisch Breathability wurde von Michal genannt, die Hydrophobität, das ist das wasserabstoßende Eigenschaften. Sie haben vielleicht den Wassertropfen auf solchen Oberflächen schon gesehen, der kugelförmig steht. Akustische Eigenschaften sind wichtig. Da haben wir Kollegen, die auf dem arbeiten. Und die lichtdurchscheinenden sogenannten transluzenten Eigenschaften spielen eine Rolle und sind auch bei der anschließenden Führung der Unit vom Nest mit der Bezeichnung DFAB wichtig. Sie können später auch diese Webpage anschauen auf nest.empa.ch zur transluzenten Eigenschaften, wie sie architektonisch umgesetzt wurde und ein marmorartiger Eindruck ermöglicht.
Aerogel Architecture Award focuses on refurbishment with aerogels and realized solutions. we have been searching for the best projects from Austria, Germany, and Switzerland to showcase this realization from architectural studios and civil engineering studios.
Mit dem Award haben wir Beispiele gesucht, die die energetische Ertüchtigung von Gebäuden in den deutschsprachigen Ländern Österreich, Deutschland, Schweiz an guten Beispielen zeigen. Es sind Projekte von Architekten und Planungsbüros.
Aim of the award is to highlight great examples of aerogel use, also to foster knowledge on use of aerogels in architecture and construction, and also to collect experience for potential users such as architects, civil engineers, building owners, and other professionals.
Das Ziel ist, gute Beispiele hervorzuheben, bei denen Aerogel-basierte Produkte verwendet wurden in Gebäuden. Die Auszeichnung der Award will das Wissen stärken und auch neue Anwendungen breiter bekannt machen. Hier will ich schon mal hinweisen auf die Innendämmung von Dämmputzen, die im Beispiel vorkommt, die immer mehr verwendet wird. Es hatte zuerst mit Außendämmung begonnen. Weiter hoffen wir damit, unsere Sammlung von Beispielen, die tiefer dokumentiert sind, zu erweitern, mit ihrem Nutzen in der Architektur und in der energetischen Ertüchtigung von Gebäuden. Und diese den Entscheidungsträgern, Architekten, Planungsbüro näher zu bringen, aber auch Hauseigentümer, Bauherren und anderen Berufsfachleuten im Gebiet.
This award would not be possible without support of our partners. Fixit, producer of Aerogel Render 222, Agitech, reseller and producer of silica aerogel products. Our golden partners are also present here at Nest, so people can visit their presentation booths. And for people online, you can join GatherTown and join our room with exhibition of the posters at GatherTown.
Gut. Michal Ganobjak hatte gerade von dem Stichwort GatherTown gesprochen. Das ist die virtuelle Konferenzroom für den zweitägigen Anlass, der gestern auch schon stattfand und von dem wir jetzt von 3 bis 5 ein Streaming machen, damit auch Bauherren, Architekten diese Fachdiskussion, diesen wissenschaftlichen Anlass im baubezogenen Teil mithören können. Der ganze Anlass war möglich dank den Beiträgen unserer Sponsoren. Wir haben als Sponsoren Fixit, der Produzent des Aerogel-Dämmputzes Fixit 2:2 und Agitech, ein Pionier in der Anwendung von Aerogel-basierten Produkten. Ich habe mit Agitech und der Mutterfirma Agi schon vor 2008 zusammengearbeitet. 2008 hatten sie mit Matten am Bau den Aerogel-Markt im Kontext von den Ortsbildschutz, teilweise denkmalgeschützten Gebäuden eröffnet. Andere Länder sind mit eigenen Firmen dazugekommen oder mit dem Hersteller der Produkte. Deswegen war anfangs die Rolle des nationalen Vertreibers. Viel Wissen wurde aufgebaut, es braucht spezifisches Wissen am Gebäude und Architekt hat auch Plattenprodukte, mehrere Dämmputze von verschiedenen Herstellern. Es ist wirklich ein Know-how-Träger von Aerogel-basierten Produkten. Und die Silbersponsoren werde ich auch jetzt schon nennen. Advapor, der Verband der Produzenten zusammen mit Verbandsteilnehmern aus dem akademischen Sektor. AIA, eine Schweizer Firma, die auch einen eigenen Aerogel-Dämmputz entwickelt hat und bekannt ist für ihre naturnahen oder natürlichen Produkte für die Fassade, Dämmstoffe, Putze. Und Hasid ist auch ein Produzent vom Aerogel-Dämmputz. Es ist die Schwesterfirma von Fixit und das Produkt ist unter der Bezeichnung Hasid Fixit 2:2 bekannt und auch in unserem Wettbewerb hier dabei.
Next thanks belongs to Advapor, Association of Advanced Porous Materials, also to Haga, producer of Aerogel render, and Hasid, sister company of Fixit and producer of render Hasid Fixit 222. We are very thankful for their support. Without them, it will be not possible. In the awarding part, we will hear about the nominated projects, mostly in German, but they will be translated into English. Yeah, maybe. Okay.
Ja, im Teil des Awards, der Auszeichnung, werden wir die Auswahl der nominierten 3 Projekte sehen. Die 3 Gewinner, Architekturbüro, präsentieren selbst ihre Projekte. 2 in Deutsch, eine in Englisch und ich werde dort dann in der Gegenrichtung übersetzen, beziehungsweise der Präsenter, möglicherweise auch selbst.
In this closing session, you will hear more about research of fibrous aerogel materials and application of insulating materials from 2 of our main partners, including innovative approaches from Switzerland.
In der kommenden Sitzung, hier im Kontext der wissenschaftlichen Forums-Session genannt, geht es um faserhaltige oder fasergebundene Aerogel-Produkte, Matten, möglicherweise auch Platten. Dann von unseren 2 Partnern des Awards, Anwendungen von Aerogel-basierten Materialien, mit dabei auch innovative Projekte aus der Schweiz, die jetzt laufen oder schon abgeschlossen sind.
As mentioned, forum will continue with the building-related presentations, which are mainly held in English, but for time efficiency, we don't translate them into German, and we can give also floor later to
Aus Zeitgründen ist das Folgende bis etwa 1650 auf Englisch. Danach folgt der eigentliche Award-Teil. Wir freuen uns, wenn Sie dabei bleiben und freuen uns auf das Eintreffen der Gewinner vor 17 Uhr. Dann geht es in Deutsch und Englisch weiter.
Okay, I can give a floor to moderator of next session, Dr. Shanyu Zhao. Yeah, thank you, Shanyu, and floor is yours.
You're muted, Shanyu. You're muted.
Sorry. Okay, now it's good. Yeah. Now we come to our last session. Yeah. So as my colleague Michal Ganobjak mentioned, we will have a joint session for the application in the market part 3 and Aerogel Architecture Award ceremony. And you could see I also changed my background to the ceremony. And after this session, and then we will have the closing remark from Manfred, and then following will be this ceremony. Please stay with us if you are interested. Then in this session, we will have 3 presenters, and the program will be slightly different. So our first speaker will present 15 minutes plus 5 minutes Q&A, but the following 2 speakers will present together for 30 minutes plus 10 minutes Q&A. Let's welcome to our first speaker, Professor Ákos Lakatos from University of Debrecen, Hungary. He will present us the systematic research results of fibrous aerogel insulation. Professor Lakatos? Yeah, the stage is yours.
Good afternoon, everybody. May I have a question? Can you see me and can you hear me? Can I have a feedback?
We can hear.
Yes, we can hear you. Yeah, sorry.
All right, perfect. Can you see my desktop as well? My share screen?
Yes, everything's perfect. You can just
All right. Thank you very much. So it's a pleasure for me to being here and make my presentation. I warmly welcome everyone through Zoom and through YouTube and there in Empa. Hope next time we can be together, maybe in Switzerland, with the other researchers from abroad. The title of my presentation is Systematic Research Results of Fibrous Aerogel Insulation. I'm Ákos Lakatos. I'm Associate Professor at the University of Debrecen Faculty of Engineering. Firstly, I would show the content of my presentation, what would be firstly the introduction, and I would give some overview of the thermal insulation material, especially the super insulation materials, and then I would show you my laboratory, and at third I would present the measurement results of my research. As everyone knows, the insulation materials can be grouped to different types, for example, conventional ones, what is the wool jumpers, expanded extruded polystyrene, polyurethane, and the others. There are the natural and alternative insulation materials, but nowadays the nanotechnological or so-called super or advanced insulation materials, and their use is widespread, not only by buildings. I mainly do research on aerogel blankets, but never forget the others. I also test VIPs and the others, conventional and unconventional insulation materials. But today I will present my results about an aerogel blanket. In the University of Debrecen, we have the building physics laboratory, and there made research on the one type of aerogel blanket, and I would show you what I reached in the last 7 years by testing this material. Here in the laboratory, I can test individual materials. We have a drying apparatus and a climatic chamber, Venticell and Climacell, in combination with a milligram preciseness balance. Here in the drying equipment, we can thermal anneal and dry the samples up to 250 Celsius degree. The wetting in a Climacell chamber can be done at several temperatures and different relative humidities between 20 and 90%. The wetting of the samples are done usually by deriving the rules of the ISO 12771 standard. Regarding these aerogel samples, I tested at least 3 samples during the measurements, and their geometry was 10 times 10 centimeter. Here you can see. Having the mass both of the wet and the dry sample, one can easily calculate the moisture content of the sample. We had 2 nice equipments for measuring the thermal conductivity, one for big samples with 30 times 30 centimeter B's area. This is the holometrics lambda heat flow meter. And we also have a small, fast and very good equipment, what is an H446 HFM for measuring smaller geometries with 20 times 20 centimeters and smaller heights having 1 to 5 centimeters, while in holometrics we can measure up to 10 centimeters. We have 2 calorimeters, a bomb calorimeter, what is a Cal2 type, and an HDSC Sirius 3500 for measuring the calorific parameters and calorific values of the samples. We can measure by the ISO 8990 standard what is the guarded hot box method. Here, where you can see on a brick-based wall covered with the space loft aerogel, and here you can see the cold chamber, a warm chamber, where the cold chamber can be cooled down to minus 25 Celsius degrees. And here you can see the big brace wall and on the insulation covered with this and the guarded box here on the warm chamber. This all made by 0.5 meter thick EPS, and outside it is a 25 centimeter thick EPS with a hot box. What are the main aims of my research? As most of you well know that the thermal conductivity, and it was the main topic before my presentation in the roundtable, that what about the thermal conductivity in laboratories by manufacturers, etc. We should know that thermal conductivities, mostly the measured thermal conductivities, different from the environment, and it is affected by various environmental cases, for example, the moisture, temperature, the time or the lifetime, the density, pressure, and we could follow this row with some others. Now, today I would give my talk on moisture and temperature as well as pressure related measurements and some others also. Okay, let's see. What I tested is a silica amorphous silica aerogel blanket. Here you can see the scanning electron microscope images of the fibers and the net with the contaminants. As you see, most of amorphous silica oxide, and we can find metal contaminants inside the energy dispersive profile. What are my results? Firstly, on individual samples, I was looking for how the moisture affects the measured thermal conductivity. For this, I used the wetting method, where I treated the samples in a humidity chamber for 23 Celsius degrees, and the relative humidity was varying between 0 and 90% relative humidity. I tried to find moisture conversion coefficient for two cases when we had initially a dry sample, and then it was wetted, and after reaching the equilibrium, the thermal conductivity was measured. And another method, if we fix at the relative humidity to 50% at 23 Celsius degree, we can find, and I could find 5.2 and 8 for the moisture conversion coefficient and moisture-related thermal conductivity. By using the wall structure and the hot box methods, I tried to find out how the direct water affects the thermal resistance of the wall. Firstly, I covered the wall with the aerogel blanket, and then I sprayed on the wall different amount of water, and you can see that relating the moisture content, a dry direct water content on the surface, the resistance was decreasing, having about 20% direct water on the wall. The thermal resistance decreased about 20%. I tested mechanical fixings, the effect of mechanical fixings of the wall. You can see here the brick wall, the cross section of the brick wall, and I tested two cases where I had firstly 5 anchors and then I had 9 anchors, and I estimated the effects of the anchors through the wall. The wall surface area is 1.44 square meters. As a result, I found a point thermal transmittance for about 0.046 as an average for firstly, and a specific value for a square meter about 0.046. Then I have tested the effect of the thermal annealing if we try to use the materials as an insulation of pipes transporting, for example, hot water or steam. I made 2 rows, what were an isothermal one, where I fixed the temperature at 70 Celsius degrees, and I made an isochronal test row where I varied the temperature, the treating temperature for 1 day, from 100 to 210, and I kept them in the venticell apparatus for 1 day. You can see the colors were changing of the samples after annealing, and for this I measured the thermal conductivities, but for the first one I didn't observe any change, but after the thermal annealing I deduced a stepwise function for changing the thermal conductivity. But this thermal conductivity is not related to the temperature. The changes in the materials are related to the temperature, And for this to see the made changes by the temperature, I first checked the samples with a scanning electron microscope for the isothermal and the isochronal as well, where you can see that the granules are separating down from the fibers, from the net fiber. And for the isochronal ones, big grains were merging and they were connecting to each other. We have revealed the changes with the structural changes with X-ray, with X-ray diffraction. Here you can see that we firstly had an amorphous silica oxide peak, then we had changes and the peaks were separated, and we had 2 peaks after the changes. So we can see that after the thermal annealing, the structure was changing. We also made the DSC. We also used the DSC equipment to estimate the heat capacity and the changes. Here you can see a melting after of the plastic part of the sample at 250 Celsius degree, and we measured absorption isotherms, both for the unannealed or as received and for the annealed samples, where we can deduce a change in the surface. Then I have tested the thermal conductivity with the HFM with the small equipment, where I tested the thermal conductivity at different mean temperatures from 0 to 70 Celsius degrees. And from these temperature variated thermal conductivities, I could deduce a temperature conversion factor with about 0.0027. This equipment not only measures the thermal conductivity with fixed load, but we can change the applied load by pushing together with the transducers of the sample. And as you can see, due to the applied load, the material is shrinking and the thermal conductivity is decreasing. Here you can see that the thermal conductivity in the function of the applied load from 0.5 to 14.5 kilopascals, the thermal conductivity is increasing, but it goes to a minimum, what is okay, and it is physics, because we cannot push entirely the sample. So this decrease stops at a certain, after reaching a certain applied load. By the pressing, the densities, the measured density is decreasing, and here you can see that these also goes to a minimum, this thermal conductivity. With the HFM, we can also test the specific heat by a step-by-step method, where we measured from 20 to 65 Celsius degree between 943 and 1304. In comparing back with the DSC, we measured with this equipment lower specific heats for the same temperatures, but as you know, it comes by the nature of the measuring equipments, because in a DSC we measure only a couple of milligrams, 5 or 10 milligrams, while in the HFM we measure regular samples. Same samples are used for thermal conductivity measurement. Before this presentation, there was a round table, and it was a theme that what about the combustion of these materials? So yes, we also measure the combustion and the combustion properties of this material with the Cal2 Eco equipment. we measured the gross combustion heat about 7.5, and after this we examined the residuum by scanning electron microscope, where you can see the amorphous bulk structure of the samples. As a conclusions, I would make a little comparison, a little conclusion of my results, what I made on as the thermal conductivities, the thermal transmittances, moisture-related results, specific heats, thermal degradation, and combustion or the burning was also tested. Now I would say thank you very much for all the Empa colleagues who were making this nice 2 days through this gather and through the Zoom as well. And what I showed you now, it was part of my postdoc research, and I hope I can follow and continue this research on these material, on other materials. Thank you very much for your attention.
Thank you very much to you, Professor Lakatos, for that very interesting talk. So I see we have several questions for you here. One question from Stefan Mühle. Do you want to ask, Stefan? Unmute yourself.
I see some questions through chat. Yes, right now the standards are very unspecific on the load applied for matrices. It's an interesting question, because when we use the holometrics equipment, we didn't know the load what was applied for thermal conductivity measurements, and what is given by the standard for fibrous materials is about 2 kilopascals, 2.5. Is it acceptable, Professor Müller?
Professor Müller, we cannot hear you. I see you are also unmuted, but I still cannot hear you.
Yeah, better now?
Now it's good.
Yeah, somehow my microphone was cut off to a different setting on my computer. Sorry for that. The topic really is, it makes it really difficult to compare published results when there is no standardization in the terms of the pressure that can be applied during the measurement of fibrous materials. Yeah, I've seen a variety of figures being published. You're talking about 2.5 kilopascal. Other standards mention up to 1.5 kilopascal as a sensible load that you can apply, but there is no real definition on what the maximum load is that you could apply during measurements.
What we know from the manufacturer of the equipment as well supposes the 2.5 kilopascals. Mm. With this equipment, you can switch off the load and you can move the heat flow plate where you want. So you can fix I was testing a lightweight fibrous material where we used the 2 kilopascals and another material, not an aerogel, and it pushed from 3 centimeters to 0.5 centimeters. So this is why you can use an own thickness for the measurements, what is more reliable than the compressed one.
Yeah, coming from more the industrial point of view, there must be a reasonable load that you see in the day-to-day application of the product that you test. Yeah, and I'm missing the standardization at this point. It's not your fault. It was just interesting to see that you're getting the same results in the evaluation that you do. So, thanks very much for your answer.
Thank you very much. Another question from I see that.
Yeah, Mira. Yeah, you could also unmute yourself.
We can go down only Yes, we can go down to -10 Celsius degree with the temperature. It has a cooler, a durable cooler, but I not really understand the question.
Miro, could you please unmute?
Hi, Lakatos.
Yeah.
Can you hear me?
That's good. Yeah,
Yes,
that's
I
good.
can. Thank you.
Okay, thanks for your presentation. We also have the same HFM446 machine in our lab, and we understand that we can also test the thermal conductivity at a negative temperature
Yes,
as low as I think with this machine at -20. So I was just wondering if you have ever tested the same kind of evaluation that you showed on the load or other effects for negative temperature measurement of the thermal conductivity.
For the load measurements, I used 10 Celsius degree. And for the temperature low, I went down to 0 Celsius degree, but I could measure down to -10 Celsius degree. But the load measurements were done at 10 Celsius degree.
Okay.
For the mean temperature.
Okay. Okay, thanks.
All right.
We have another question from Michael O'Connor. Michael?
Yeah, I was just really,
Yeah.
if you're a certified test body.
No, I'm sorry, we are not certified, but we follow the rules and standards. And we in a university measure sometimes for companies. So I can send you my email after.
No, it was only also from the round robin, you know, we had a discussion about if you are going to publish, you should perhaps do a testing to a certified test body. So you seem to have a lot of equipment. It looks pretty interesting.
Yes.
Thank you.
Thank you very much.
If there's no more questions, we can move to our next speaker. So then we still want to thank again Professor Lakatos for your nice speaking.
Thank you.
Next, we will have two presenters from industrial, Mr. Michael O'Connor and Mr. Sebastian von Stauffenberg. Mr. O'Connor was the vice president of sale at the Aspen Aerogel, and in 2019, he set up his consultants company, Orlanna Associates, and in the past 3 years, he also headed up a nanoporous materials association at WPB, and he is now the managing director of Orlanna Associates and the president of WPB. And he will present together with Mr. Sebastian von Stauffenberg. Mr. Stauffenberg is the manager director and owner of Agitech, which is specialized in the distribution and the consulting of aerogel products in the construction sector for over 10 years. And Mr. Stauffenberg and his team is always looking for a new application and possibilities of aerogel products in the Swiss market. So, and now, Mr. O'Connor and Mr. Stauffenberg, you can coordinate yourself, and we will see who is present first.
Okay.
Yeah, please follow yours.
I think you, Mike, first.
Yeah. Oh, I didn't expect that. So I'm just trying to find my screen. Maybe I should have practiced this before.
Yeah, it's good.
This is what I'm going to share. So is that working now?
Yes, we can see you perfectly.
Okay, great. So I was going to talk about ADVAPOR, which is an association some of you may well know about, but just a chance to introduce it and maybe to solicit a few more members from the attendees today. So ADVAPOR is the Advanced Porous Materials Association. We set it up in 2017, basically to represent aerogel and advanced porous materials, the other materials, a little bit like Kalistad from Evonik, which have less than 20 milliwatt performance at 10 degrees C, and you know, generally considered as an aerogel type, super insulation type material. We set it up in response to some work at the International Energy Authority. There was a working group to look at super insulation materials in the building industry. And the companies that you see here, there were 7 founding members. We were all talking with the same voice, but we really didn't have an association or a single body to represent our interests. And so we set up an association called, as I say, ADVAPOR. It's based in Strasbourg, registered in Strasbourg, because I live in Strasbourg. So it was very convenient for myself. The actual original idea was from the company Renaissance. You know, we heard from Brice yesterday, but the original person stepped out of the company, and I took over the presidency of the association. Georg Gärtner von Cabot is the vice president, Francisco Reyes is the treasurer, and Brian Cahill from Aspen is the secretary. Bettina of Gerhard from Evonik and Barbara Miller from the DLR have been founder members and very active members as we go forward. The aims of the association are quite simple. We wanted to create a platform where the community can meet. So similar to today, it would just give another format where we could have our annual general meetings and such like, and we'd be able to get together. We'd be able to address the hurdles. I think a couple of the presentations that we've heard over the past 2 days certainly have talked about how difficult it is perhaps to enter new markets. I think I heard quite often, what about the dust, the safety issues? I mean, each company has had to address those individually, but we felt as an association we could perhaps give more gravitas to that discussion. Testing, again, we just had the discussion now about what load pressure is suitable for an aerogel, the standards that you use, and then the general marketing. So typically, I mean, you know, it's to develop and grow the global potential of these new materials. I think everybody who's listening in today are probably good fans of the material and all understand that there is a challenge to develop and grow. Obviously, the benefits of being a member is the networking opportunity, you know, the chance to meet with other people. So I think to have more of this type of exchange that we're having in the last 2 days is really important to go forward. Share data, learn how other people are using APMs, I think is good. And the global standards. We're lucky enough that Brian Cahill from Aspen is a member of he's managed to get himself and Aspen as a member of the ISO standards committee that are working on the new global aerogel standard. And so he's been very helpful in educating us about what things we might need to act on within this ISO standard procedure. And then another benefit, although I don't know if it's really huge, is that, you know, the ADVAPOR logo we tried to reserve for the members of the association, and as we go forward, hopefully we will be able to put some value to that, our association, and being a member of it would be some sort of endorsement of quality, I would say. The goals for this year, I mean, we are 20 members presently. Personally, it's my goal, it's my own challenge. I would like to grow that to 30 members. I'd like to grow it globally. You know, we have companies in the US and Europe. We don't have anybody in Asia or Latin America or Africa as present. So anybody who's listening, if you'd like to join, I'll give you some details on the next slide. But it would be great to sort of just to see positive growth. From the group that we are already, we have actually created a bursary package for the best PhD working in advanced porous materials. We've done that for 2 years now. We typically do it in parallel with the aerogel seminar in Hamburg that Irina runs. And that's been quite successful. We've been able to see quite a lot of very exciting PhD work and then reward what we feel is the best out of that submissions. And we also wanted to create an award scheme for the best advanced porous material application. And of course, just straight after this, we are helping sponsor the project of Empa for the award ceremony in a few minutes. So we've sponsored the seminar on aerogels, as I mentioned. We also sponsor Barbara Milau's workshop in Cologne. And so we're moving, we are moving forward. Last few years have been quite a challenge for everybody. We have 4 types of companies that are in the makeup of our association members, as the large companies who have revenue above 2 million. So that'd be the Aspen, Cabot, Evonik type of companies. We have a few startup companies who are smaller and obviously growing, and then people who are working in research and academia. So if you are interested at all to join this community, it's a very good time because membership is free. We decided, due to all the challenges that everybody's had over the COVID period, that we just going to make membership free of charge for the next year. There's a link here on this slide, Advoport organization. So I would invite, if you are at all interested, it would be a nice place to be, and we could have another meeting together when we have our annual general meeting, either online or in person if things go our way. Okay, so that was it really. It was very short and sweet, and I wanted to give Sebastian a little bit more time to present some of his exciting innovation projects. And Sebastian, if you're ready, you could take over, and maybe we take questions at the end, if that's okay with you, Shani.
Yes, sure.
Okay.
So you two coordinate
Okay.
each other, and we will have the questions at the end. That's fine.
Okay, great. So
somehow it doesn't work. Do you see my screen?
Yes, I can see your screen, but the presentation, okay. Now it's here.
Now
yes.
It's here, yeah. Okay,
yeah.
Perfect.
That's good.
So,
yeah,
thank you. Good afternoon to all. And first, I would like to thank you for the opportunity to present here our work of the last years. My name is Sebastian. I'm the CEO and founder of Agitech. And I would like to show you some application and innovation projects that we had in the last years here in Switzerland. And first I would like to introduce you shortly our company, and then the applications and projects. First, a few words about our company. Our main company is AGI. We are an installation company for technical insulation and structural fire protection with over 400 employees and market leader in Switzerland in this field. But we have also been one of the first companies that started to resell Aerogel products. And we started the cooperation 2008 or even before. It was also with Mike O'Connor when he worked at Aspen Aerogels, with Aspen Aerogels. And out of this cooperation, we founded a spin-off, Agitech, that is specialized on reselling of aerogel products. Our philosophy is not only to distribute aerogel products, but above all to advise and to develop solutions together with our customers. In many areas, we have been allowed to do pioneering work. We tried to establish Agitech as a competence center for aerogel. So it's not only the sale of products that it's important, it's really to find solution for different problems that you have with standard insulation material, and that's important. The main products that we are selling in Switzerland, you can see on this slide, it's we started with the Aspen Aerogel fleeces, mainly space loft that we use in the building construction sector but also the other products for industrial applications. But Spaceloft developed as our main product that we are selling. And as you know, the fleece comes on big rolls. We started to fabricate also boards out of the rolls and glue the different layers together to boards so that we have boards that are thicker than 10 millimeters than the standard material is. And later, it was in cooperation with BASF and Aspen Aerogels. They developed the product Slantex. This is still available on the market, and we are also selling this product. That's more for if the fire rating is more important. It has a fire class of A2, and we can use this material up to 600 degrees. We have also an alternative product that we call Spaceloft A2, and also a new product that we developed in the last 2 years and started to selling this year is the product PureFlex. It's our own development, and I will speak a little bit more about that later. Why we are so convinced about the fleeces and not maybe about the rand or the other products that are on the market that are also good. The fleeces has the opportunity that you have a very flexible and easy to cut material that you can use for different forms. It follows the architectural forms, and also the fire rating is very good if you have the right fibers like glass wool. And of course, like the other aerogel products, also it's vapor open, and that's very useful for retrofit of old buildings. Nevertheless, the handling is not always so easy. It's important that you explain the craftsman well how to use the material. Otherwise, it can happen that he is a little bit frustrated because the products develop some dust if you use it. So you have to protect yourself, and you have to know how to cut it best. But if you know the tricks, it's a material that is very easy to glue, to cut, to drill. So therefore, we had never really difficulties to install the products on the building construction sites. Where we use the material, it's mainly, of course, where you have not enough space for traditional insulation material. Here are some examples that I will show you on the next 2 slides. If you have an old building, this on the picture is like a standard building. You have thousands in Switzerland from the 1560s, last century. You have a lot of details you have to solve when you want to retrofit this kind of buildings. And often the price of the material is an issue if you only compare the price with another traditional material. But if you look at such a building, you have a lot of problems to solve, like the eaves, the window reveals, the window seals, or like your terraces. And if you calculate the total cost of the renovation, it can happen that the renovation with aerogel is not more expensive than with a traditional material because you can save all the details. And that's important in the calculation. And also, of course, the aesthetic is also a big impact. And in this case, we have made a retrofit of the building with 2 centimeters of aerogel, and it looks almost the same after the renovation. And also, if you have structures on the buildings, it comes, for example, from stone wall, and you see in the big picture, this is like a relief with the fleeces or the boards of Aerogel, you can easily imitate and save these details. Often it's not possible to insulate or retrofit outside the wall. So therefore we're using Aerogel also internally. Of course, it's a little bit tricky with condensation between the insulation and the wall. And so we developed also a system with a vapor barrier you can use, so that it's not that risky to use Aerogel also inside the building. Here are some other details that are very often, we very often use Aerogel in Switzerland. For example, roof hatches, doors, window frames, terraces, all these thermal bridges that you have in every building. If you make a retrofit, there are always possibilities to use Aerogel. Oh, sorry, that was too fast. Here are some other details and thermal bridges where we use Aerogel very often. It's window reveals outside. Also, if you use standard material for the whole facade, you have the window reveals where there's no space normally. You have the frame widening, window frames. We have radiator niches. And very often in Switzerland, we use Aerogel also for ventilation and air duct systems between the different floors. Together with, or BASF has developed also ethics systems. It's many years ago, they stopped to selling these systems, but we still sell it on the market. It's called AIA. It's, as I know, the only proved and certificated ethics systems with Aerogel that we really very successful introduced in Switzerland. Here you see some example of buildings that we have used Aerogel ethics systems for retrofit. This building you see here, it's an old mill house. It's, I think, the first building in Europe or maybe in the world that it's completely insulated with Aerogel with 3 centimeters of space loft. That was 2008. And since then, we have made many buildings and very different kind of buildings with retrofit Aerogel systems. Here are some other buildings all over Switzerland, and also new buildings like this apartment building in Aosa in the mountains is completely insulated with Aerogel. The goal was to have as thin as possible facade, and more and more we yeah, it's also interesting to use Aerogel for new buildings. We heard this yesterday from Yanis Venery, that if you have a certain value of the ground, it can make sense to choose Aerogel and to save space, and this can compensate the additional costs of Aerogel. We found out that it's around 9,000 Swiss francs per square meter when it makes sense to use Aerogel. Now I want to show you some innovation projects of the last years. We have been part of a Horizon 2020 project called WallAs with different partners all over Europe to develop a new kind of Aerogel render. We have tested also at our facility all kinds of different Aerogel renders on the market and the new solutions. The product is not available until now on the market. It's still in progress to bring it on the market. Another innovative project at the Empa, it's a unit called the Nest. Together with the ETH and other partners, we have developed a process to fill in aerogel granula in a translucent membranes element facade. And here you can see on the picture that it looks a little bit like snow, and it's translucent, and especially in the night it gives a very interesting aesthetic impression. Yeah, I don't know if you're at the Nest, you can visit it. It's on the top on the building. Another project that we could realize, it's the project Hohlstraße. It was a new building, and the complete front side of the building was made with prefabricated wooden frame elements with aerogel boards, and the total facade thickness was 140 millimeters. So here we could save 60 millimeters of thickness, and that so that it was possible to have 1.5 mini apartments more. Another big project is in Lyon, where it's one of the biggest buildings in Switzerland. It's 1.1 kilometer long, and the whole facade had to be renovated. And at the beginning, it was planned to make it totally with aerogel, but at the end, we could at the balconies we made elements with aerogel. But it's a huge project that it's running since 8 years, and it also takes often. That's our experience, that the aerogel project takes often very long until it gets realized, because many you have to convince many different parties of a project. Especially the combination of timber frame and aerogel. We look at it's very interesting, because here you can win much more space. Here on the right picture, you see the difference between a standard wood element and with aerogel, and we could reduce the wall thickness from 27 centimeters to 15 centimeters with a very good U value. And this building is located at the lake of Zurich. It's also called the Gold Coast. So it's very expensive ground there. And so it made really sense to use aerogel for this building. And there are many other buildings in the area of Zurich where it makes sense to use aerogel. But until now, it's hard to convince the architects or the owner. Another project that I think also Yanis showed yesterday is a project, and we try now more and more to recycle aerogel, because we have a lot of waste of aerogel, and it's a pity to throw them all away. And our idea is to make small pieces of it and use it as a blowing-in insulation. And with our new material, PureFlex, we got quite good results. It's much easier to cut than Space Loft or other fiber aerogel fleeces. And we got until now we got a lambda of 0.02. And so that could be interesting for also for wood timber frame construction. And of course, we also think about to combine aerogel with CLT wood to make panels of it. That's a little bit our vision, to be even more thin and not to have thermal bridges like in the way we do it until now. Some words about our new product that we have developed the last years and introduced this year in the market, PureFlex. It's a little bit different than the material, the fleeces that are on the market until now, because it's the first aerogel product that is based on a foam. It's a polyurethane foam filled with aerogel. So we fill the pores with aerogel. And at the end, you have a material that is very flexible, but also very easy to cut, much more easy to cut than other fleeces. And it has also a surface that is very smooth, that makes it much more easy to glue, for example. And also it makes it more interesting if you have elbows, for example, for pipes and industrial applications. It has a lambda of 16. It's a certificated value. Here are some pictures of the production. We are not producing it by ourselves. It's a cooperation with an industrial partner. And we also cut the rolls to boards and glue it together, like you see it in the middle. And we're also covering with aluminium for low temperature applications. Here are some test applications that we have done this winter with the new material. We also try to develop ATIC systems with the new material. And we see many different other applications for PureFlex, because the material is very light, so transport could be very interesting. The pipes, air duct systems, industry applications, but of course also the building envelope is interesting, retrofit and new buildings. That's a short overview about our work and our project. Thank you very much for your attention, and you'll find more information on our homepages. Thank you very much.
Thank you, Sebastian and Michael, for the nice, very interesting two presentations. There are many questions. There are two questions. One question from Zara Mazrui about is there any special method to cut the blankets regarding their dusty behavior?
Sorry, I was looking for the. Can you repeat the question? Sorry.
Yeah. Is there any special method to cut the blankets regarding their dusty behavior? Like, if you cut it, maybe the aerogels just
you need
particles come down.
If you cut it in big quantities in the facility, of course you need to encapsulate the manufacturing, and otherwise it helps if you have a mask, if you wear a mask, and cutting the material, it's the simplest way. If you have a knife that is maybe Mike, you can help me a little bit in English.
Yeah, sure. I would say that, you know, over the years, certainly with my experience with Aspen, you really need to train the people who are handling the material. It's not a good idea to send certainly an aerogel blanket out to a person to do it as a do-it-yourself or home installation. But I think once you train a contractor or somebody to cut the aerogel, and you can develop techniques. And I think the number of challenges we had just dropped off dramatically. I mean, Aspen certainly is selling a lot of this material, has a very active training program. I know Sebastian's the same in Switzerland, that they only work with select contractors. And in fact, a lot of the material sold is in board form, pre-cut board form. And once you get to a rigid level, once you have one laminate in the blankets, it's a lot easier to handle, that's for sure. But yeah, I would say that you need to maybe have a look at some training program if you are experiencing a little challenge from the dust. But there are techniques to manage that for sure. I hope that covers a little bit of the question there.
Thank you, Michael and Sebastian. Zara, if you are satisfied, if you want to have more questions, you can just unmute yourself and ask.
Yes, thanks, Shanyu. Thanks for the presentation. Yes, my question, I got a little answer about that because for the aerogel products in the market, all of us know that aerogel blankets are not 100% complete products, and a lot of drawbacks is covered with the installation. And this is a question that silica is kind of abrading materials, and maybe because of this, I asked this question, that there's a problem when the handyman in the on-site, they want to cut the products, and for the different spaces and different size, they need some special cutter, or no, they are using some usual cutter that we are using usually in the other works on site, or no, Aspen have something special to introduce them?
Not special cutters. I mean, I think you just need, the contractors themselves will have a variety of tools to cut. I mean, you don't want a really big jagged sawtooth type blade. You want a relatively smooth blade. But I think really, if as you get into this, you find your own techniques for cutting. And I say there's a lot of material being installed around the world now, a lot of experience gained. But yes, you just have, I mean, the contractors are very skilled, typically, if you use the right contractors in how to handle a variety of materials.
Yes, okay, thanks.
Okay, our next question is from Amira from Crosslinker, Singapore. I think this question is to Mr. Stauffenberg. Amira, do you want to ask, unmute yourself and ask? Or I can just read it.
Yeah, sure. So I've seen in one of the initial slides that they said that the Space Love and other products are available as thick as 100 mm thick board. So I was just wondering whether these kind of like products are commercially available, and if yes, for which kind of application are you targeting these thick boards? Because we all know that one of the selling points of this kind of like aerogel products is being thin and lightweight, and also could be a space saving.
Yeah, thank you. The product normally from Aspen is always 10 centimeters thick, the fleece, but we cut it to boards and glue it together several layers up to 100 millimeter thick boards, so that are available, but not directly from Aspen, but from us. And we use this, sometimes we use it for new buildings, because if you, and for Switzerland, if you want to reach the standard U value that it's needed, you need 80 or 100 millimeter of aerogel.
Okay, so you mean you are not producing as 100 mm thick, you are trying to stack the material to reach to the certain thickness that is required?
Yeah, it's laminated.
Yes.
Right?
Yes.
Yeah, the lamination process, yeah.
Yeah. Oh, okay. Okay, okay, thank you.
Thank you.
Thank you. And our next question is from Roman Subramaniam. Yeah, sorry, so my pronunciation.
This is a question to both Michael and to Sebastian. First to Sebastian regarding PureFlex. What is the price point of PureFlex? Is it same as Aspen, or would it be different or more?
Yeah, it's yeah, it's a little bit different. It's not, but the difference is not so big. It's a little bit. The price is a little bit better. Yeah.
And the more general question to both Michael and Sebastian is: what is the price point of an aerogel which you think can open markets, especially in the insulation business?
It's a very good question, but a good person to answer is Yanis Venere. He's just done an excellent survey and a report paper where he's tried to calculate because it's all about space. If you're in the building and construction, it's all about space saving. So if you're saving space in the center of London or on the Gold Coast of Zurich, then the price point is much higher.
Fair point. But these are all specific cities. The general question is, if you want to open the aerogel market for building insulation across, say, richer countries like Europe or in America, what would be this price?
But then I would only challenge you, Armin, that there isn't the capacity. You have to step change. If you come down to €100 a square meter sort of real estate price, then there is no capacity in the world that could meet that demand. So I think it's the other way around. I think you really have to say, okay, if I do London, Paris, if I had a concerted effort in these cities, what volume could I sell? And then look at the available capacity. So it's a good question. The lower you go, the bigger the market, but then you don't have the capacity and you probably won't have the profitability to do it.
I think if the product is 10% more expensive or less, that makes not a difference, because we are completely other range of price than compared to other materials. So it must be significant.
Is there a percentage for that? How significantly cheaper it should be, in your opinion?
I would say if it's 50%, the half of the price, it will help a lot. But I don't know if this is realistic for aerogel. But there are many startups I heard today, so I'm optimistic that in the future maybe there will be other products that are more competitive to other products.
And if I jump in there quickly after Mike's remark, so together with Mike and Wim and some other colleagues, we did a study on that, which we just submitted for publication. So if you have a bit of patience, you will be able to read a bit more about it. Our conclusion is, so we developed an equation to calculate when does it make sense to use aerogel for new buildings in high price areas. And the interesting finding is that it's not linear with the price of aerogel. So if you decrease the price a bit, you open the market a lot. And just please have a bit of patience, and then you will be able to calculate the numbers yourself.
Other way around, you could simply forward me the paper. It's much faster that way. I won't complain.
Sure. As soon as we have it accepted, we'll do that.
Okay.
Yeah, thank you.
Okay. Thanks all. With very interesting speeches from our two industrial presenters, and then we are approaching to the end of this session, and also the forum, the whole forum. We are ending it. We're ending the forum now. I would like to thank all the participation, like the audience and the presenters, done for this session, and also for all these Aerogel in Touch forum. And next, I would like to give my talk, my speech to my colleague Wim Mafe for the closing remark.
Can you see my screen?
Yes.
Yeah. Okay.
Good.
Perfect. Welcome to these closing remarks. I think it has been a eventful 2 days. Lots of discussions, lots of questions from the audience, lots of interactions. So I was very happy to see all of this. I think the technical tools have held up most of the time, so that's also nice to see. Always a worry as the organizer. So I started the opening talk with this slide, that there is this rapid expansion of academic research and a more moderate expansion, let's say, of patent applications. This is for silica aerogel specifically. And I think the forum has also shown this, that there is a lot of activities on both fronts. There may be a little bit of a mismatch between these two activities, but I think this is also normal because the functions of research institutes and universities is of course not the same as companies. maybe some statistics about the forum. We had about 90 participants. I think the highest single number of attendees was on the order of 86 at a given time. Most of the participants are from Europe, 12 countries in Europe, 7 in Asia, 1 in North America. There were 25 talks and posters, 14 presentations from industry and 31 from academia. We purposely gave more oral presentations, more talks to the industry presenters, because the goal was really to have a participation really from industry, not just an audience from industry, but a presenting from the industry. Since we are scientists, we like numbers. Of course, we have a very biased data set because we sort of fixed the program and we also advertised to certain communities, maybe more than to others. But even if the data set is biased, I think it still shows some interesting trends about the affiliation of the presenters I just discussed, about 1/3 industry and 2/3 academia. The materials, mostly silica aerogel, let's say almost half of the materials, and then a lot of biopolymer aerogels, and also some talks on other materials. For applications, it's about 50-50 between thermal insulation and other applications. The general balance of the presenter was not too bad overall, but all of these numbers now from all the presenters are very different if you look at the industry. So the industry's focus is really silica aerogel. Even the 2 biopolymer aerogels, you have to stretch to really say that they were working on aerogels or that this was the main focus. I think this is a reality. This is not a problem, but it does mean that there could be some disconnect sometimes between what is happening in the research world and what is happening in the industry. And then the industry is obviously also very interested in thermal insulation applications. I'm also not really sure why the disconnect with the gender balance is so extreme also in the industry. This is maybe small sampling set or something to do with the difficulties in starting spin-offs for women maybe. But I just thought the statistic was very striking. So I leave it there for what it is. So I think these trends that we see in like the statistics of the presentations are not very different than what we would have, or at least what I would have expected beforehand, that there is this continued focus on thermal insulation and on silica aerogel in the industry. I think this is quite clear. Maybe again, this is our sampling bias because this is also where we are coming from more at Empa. And then that is reflected maybe like that in the program. But we really tried hard to also find industry presentations from the aerogel field and that were not on silica aerogel and not on thermal insulation, and it was really difficult. Are there companies flying below the radar? This is certainly possible. Maybe some companies want to not disclose any information before they are ready to actually launch the product, or maybe in the worst case scenario, maybe they will start disclosing information when they have given up on a certain type of application. I think in the pharmaceutical field, for example, this is quite common, where there is no disclosure until there is a need to disclose, like from the government or from the organizational, the permitting side of view, or when they stop a product. But we have seen a lot of ideas on new markets through product developments and also various approaches to attack the cost aspect. On the academic side, the picture is very different. There's a lot of material chemistries, a lot of different applications, biopolymers, polymers, hybrids, metals, metal oxides, carbon aerogels. Any material you can think of more or less has been made into an aerogel. I think this is also good. There's also been new insights into traditional aerogel materials. A lot of new applications are targeted on the biomedical and environmental fields. At some point, there has to be a transition to market. There was already quite a lot of discussion on this in the round table. How can these other materials and other applications reach the market? I mean, if we don't reach the market, we don't reach society. And in the end, there has not been really an impact of all the research work. It doesn't mean that each research project should end in a product. I mean, that's also not realistic. But I'm partially hopeful and partially anxious to see what the next 5-10 years will bring. And of course, it would be a huge boost to the field if one or more of these materials can really make an impact into the market, the non-traditional applications. So this is the Switzerland that we promised you at the start of the event. Unfortunately, this will not be happening right now because of the whole situation in the world, but we invite everybody to come to Empa. We are happy to show us our laboratories, to show us the institutes. Maybe we can start up collaborations, and maybe we can also drive to some places in the countryside. So I want to also take the opportunity to thank again all the speakers, poster presenters, and all the participants for the questions, the interactions, Maria Lucia Hijar from the Academy for the organization, and then everybody from our laboratory. I want to point out a few people who were particularly helpful. Maybe I have forgotten a few, and if I did, I'm very sorry, and I will apologize to you in person this evening or tomorrow. Also, the Aerogels cost action, I think it's very useful to have a mechanism that is motivating people to try and set up these events. It's not only about financial support and opportunity, I think it's also a part of building a community and a network. So I think the Aerogels cost action is really helpful for this. So this is also the Switzerland that we promised. This is on the southern side of the Alps. In reality, I'm sure many of you in Europe are aware that the current situation is not like this. It's more like this picture. I hope all of you are safe, especially in some of our neighboring countries where the flooding situation seems to be getting a bit out of hand. So actually also in reality, I think right now the sun is almost shining, and this is probably the first time during the entire event. So even if we would have had the event on site in these 2 days, all the beautiful pictures I have shown you would not be available. Finally, I want to take the opportunity to advertise some future events. The Aerogels Cost Action is organizing a symposium on aerogels for biomedical and for biomedical applications. This is part of the 31st Congress of the European Society for Biomaterials in Porto. And the Aerogel Symposium session is on the 7th of September, and it should also be possible to follow that session online. So if you are interested, please look it up, and might be a good opportunity to present your work or learn more about biomedical applications. Then there's also the 6th International Online, I guess it's the first international online summer school, but it's the 6th summer school on aerogels organized by the German Aerospace Center, DLR. This time it will be a single day. In the past, this has been a great event with a lot of opportunities to learn for people. So the website will go online on the 1st of August. So mark this in your calendars, or you could already write aerogels@dlr.de to make sure you're on the mailing list. And then another third and last event that I want to advertise is 2 sessions on aerogels organized also by the Cost Action within the International Polysaccharide Conference of APNOAE in Nantes. This is in October in France. So finally, also, there is the Aerogel Architecture Award ceremony, which will start at 5. This ceremony you can follow through Zoom, so you can just stay here, or you can also go to the YouTube stream, which will be available to everybody worldwide. So we've done our work. Now we can all go home, and I'll leave you with this last picture of Switzerland. Switzerland is not only mountains and cows. There's more to it than that. There's also industry and innovation and urban areas. But I thank you all again very heartily for your participation, and I hope to meet as many of you as possible in person soon in Switzerland or at some other events in the near future. So the Zoom will stay open this time, so you can stay on for the Aerogel Architecture Award ceremony, which will start at 5. or you can, of course, call out and have a nice evening. So thank you all. Bye-bye.
Thank you so much, Wim. It was a great event. Thanks to all the team for all the efforts. It was nice to see all you guys. Really nice. Bye-bye.
Bye-bye.
Bye.
Hope to see you soon.
Yeah, we all together, no?
Yeah.
Finally.
Not only with a video.
Yeah, but also with a video is better than nothing.
Yes.
Yes.
Okay, here.
So
Bye-bye.
see you.
Bye-bye.
See you.
Bye. See you.
Bye.
Bye. Thanks all.
Good afternoon. Okay. To ones who stayed with us and are interested in aerogel use in buildings, I welcome you again on this first edition of Aerogel Architecture Award 2021.
Und ich begrüße auf Deutsch die Teilnehmenden hier im Raum, die Teilnehmenden auf dem YouTube-Channel und die Teilnehmenden im Forum. Darunter hat es auch einige deutschsprachige. Das Forum war ja in englischer Sprache.
We received 5 projects from Austria, Germany, and Switzerland. From Germany, from Switzerland, 1 from Austria. The first one is located in Zurich, a multi-family house. Then also accommodation in Vienna, university in Weimar, former mill in Madiswil in Switzerland, and a 5th project, Tübingen, also accommodation.
Ja. Wir hatten 5 Einreichungen erhalten, 2 aus Deutschland, 2 aus der Schweiz, eines aus Österreich, aus Wien. Sie sehen die Lettenstraße in Zürich, Marienhilferstraße in Wien, in Weimar ein Gebäude der Bauhaus-Universität, die Materialforschung ist hier drin, in Madiswil eine renovierte Mühle und dieses Biedermeierhaus in Tübingen, Deutschland.
Jury selected 3 projects for their qualities, and later you will see the presentation by studios and representatives of the studio who submitted the projects.
Die Jury hat 3 der Objekte ausgewählt. Kriterium waren die Qualität, der denkmalschützerische Aspekt und die Energieeffizienz.
We had a jury consisting from renowned and very experienced professionals in field of building renovations, energy efficiency upgrades, and preservation of cultural heritage. One is Professor Ralf Kilian from Fraunhofer Institute of Building Physics, architect Mr. Volker Herzog from Herzog-architektur from Germany. We have him here. Then architect Mr. Beat Kämpfen from Kämpfen, Zinke and Partners from Switzerland, and architect from Austria, Manfred Wehdorn from Wehdorn Architecture.
In der Jury ist Professor Ralf Kilian, Experte für historische Monumente und die Erhaltung im Bestand, dem Konservieren der Baumaterialien. Er ist am Fraunhofer Institut. Volker Herzog hat sein Architekturbüro in Freising, nördlich München. Beat Kämpfen aus der Schweiz ist im S-Jahr für der Präsident der Kommission für die energetische Optimierung von Gebäuden und der Architekt Manfred Wehdorn ist in Wien zu Hause.
Now I will ask in name of all jury Mr. Volker Herzog, Mr. Architect Volker Herzog to little clarify their decision making and their selection.
Yes,
floor is yours.
Thank you. Ich versuche es etwas lauter zu reden. Ich hoffe, jetzt überschlägt das nicht in der Aufnahme. Ja, die Kriterien sind gerade genannt worden. Wir hatten die Kriterien zum einen, wie ist eigentlich der Erhalt, dieser architektonische Ausdruck, also die Denkmalpflege bei den Projekten? Wie hat die Energieverbesserung stattgefunden? Und zum Zweiten die Originalität der Lösung. Ich möchte zuerst auf das Projekt in der Schweiz eingehen, in der Lettenstraße in Zürich. Dort war es so, man hat den Aerogel-Dämmputz verwendet bei der Sanierung und zwar im Innenbereich. Das ist eben eine Besonderheit, dass man diese Aerogel-Dämmstoffe eben in sehr dünnen Schichtstärken aufbringen kann und sich dadurch das Material ja auch für die Innendämmung eignet. Der Vorteil, dass eben hier der architektonische Ausdruck erhalten blieb und die Außenfassade naturgetreu saniert werden konnte, weil sie eben nicht durch irgendwelche Dämmmaßnahmen verfälscht wurde. Besonders hat uns da auch dran gefallen, dass die Wohnungen, die im Innenbereich in einen wirklich modernen, heutigen Wohnstandard umgewandelt wurden, also einen Wohnstandard, der an einem Neubau grenzt. Aber man lebt eben nicht nur neu, sondern in altem Charme, in alten Wänden. Das ist das Originelle an dieser Lösung gewesen. Ein Projekt aus Wien in der Maria-Hilf-Straße. Da ist zwar nicht viel vom ursprünglichen Denkmal übrig geblieben oder der ursprünglichen Bausubstanz. Diese wurde dann eher historisierend ergänzt an der Fassade. Das ist ein ganz legitimer Ansatz, fanden wir von der Jury, denn so blieb der Straßenzug, das Gesamtensemble einfach erhalten und das zeichnet ja gerade die Innenstädte auch im Besonderen aus. Dieses Gebäude hat dann dagegen im rückwärtigen Bereich einen sehr modernen Bau bekommen. Also hier wurde dann auch wirtschaftlicher Wohnungsbau betrieben. Hier wurde der Dämmputz, Aerogel-Dämmputz außen aufgebracht. Und man sieht, auch wenn man außen dämmt, kann man trotzdem wieder eine historische Fassade damit gestalten. Ein ganz besonderes Projekt aus Deutschland, das war eben die Bauhaus-Universität. Ganz klar für uns Architekten natürlich auch ein Beispiel moderneren Denkmalschutzes aus dem letzten Jahrhundert. Da möchte ich gar nicht so weit drauf eingehen. Dieses Projekt wird gleich noch vorgestellt, denn es hat einen Preis gewonnen. Auch einen gleichen zweiten Preis hat das Projekt in Tübingen erhalten. Da kenne ich zufällig auch persönlich die Situation. Das ist ein Mehrfamilienhaus am Schlossberg, also so das Zentrum dieser alten Stadt. Eine wunderschöne Situation und hier kann man gar nichts anderes machen, als auf diese historische Substanz eingehen, diesen Ensembleschutz zu erhalten. Und das ist eben auch in besonderer Weise hier gelungen. Den ersten Preis ist eine alte Mühle gewesen aus Madiswil. Und wir haben uns dafür eigentlich entschieden, weil dieses Projekt zum einen sehr authentisch restauriert wurde. Und das ist eben auch ein Merkmal der Aerogel-Dämmstoffe, dass man sehr behutsam mit der ursprünglichen Substanz umgehen kann, egal ob Innen-, Außendämmung oder wie auch immer, man eben mit sehr dünnen Dämmstärken auskommt und somit eben genügend Spielraum hat, die eigentliche Substanz nicht zu sehr zu verfälschen. Zudem wurden sehr authentische Materialien verwendet. Und in Kombination, das fanden wir das Besondere, was alt war, blieb alt und was neu hinzukam, weil es nicht zu retten war oder eben auch notwendig wurde im Rahmen des Umbaus, wurde bewusst neu und modern gestaltet. Und so ist eben eine schöne Symbiose aus alt und neu entstanden. Ja, das war unser Beitrag von der Jury. Die Mitglieder wurden ja schon vorgestellt. ja, ich darf mich auch da bedanken. Es hat Spaß gemacht, die einzeln eingereichten Projekte anzusehen, ein bisschen in ihre Arbeit einzusteigen und somit von ihrer Arbeit einen guten Eindruck zu kriegen und beflügelt uns selbst mit diesen neuen innovativen Stoffen, Dämmstoffen dann auch zukünftig zu arbeiten. Vielen Dank.
I will ask now Mr. Jörg Hoffmann from Planning Studio to introduce their project of renovation of university in Weimar. So with
Okay, haben wir es. Can we start? Okay. Okay. Dear ladies and gentlemen, dear Mr. Brunner and Mr. Ganobjak, dear members of the jury, thank you very much for the kind invitation and the opportunity to present our project here. And special thank you for your intensive efforts to make it as easy as possible for us to participate. Please excuse me for reading the lecture largely, but my school English is 40 years old and didn't get much practice. Before I talk about our project, the renovation of the facade from the FR Finger Institute at the Bauhaus-Universität in Weimar, I would like to talk about my first contact with Aerogel insulation material. In the year 2013, I renovated the rear facade of my own house in Weimar. And for economics reason, I take a conventional insulation with a coarse render for the main surface. Only the window survival were lacking suitable insulation material, as only a construction height of 4 centimeters in the revivals. In an architectural journal, I found an article about insulation from aerospace technology. Since architects always are typical curious, I ordered a box of 10 square meters. The price of the box was also utopian as space, but I remember the words of my professor of building physics during my studies, who said, who's built cheaply builds twice, and we are too poor to build cheaply. Today I understand it a bit better than I did then. Easy to understand that there were many questions by the construction company, but the application was quite simple and it still works well today. No mold has appeared on the inner revivals despite of a 40 centimeter thick natural stone wall. I have keep to this day a piece of insulation here from this time for me. So now to our project. The building from the FA Finger Institute in Weimar is listed as an outstanding example of GDR architecture for its construction period of 1958. Anyone who knows a bit about the economics condition in socialism knows what an achievement the architects of that time accomplished. The building is still in use today for his original purpose, science and research. The original inner layout still works well. All too many functions inside are urgent need of renovation. The achievement of the 1950 architects was an obligation for us today. And whenever architects have a claim, the problems for the client begin. what were our problems? The external render, the external render were desolate with caves behind. We see little details. The concrete window stills were in the same condition here. The windows are fungal infestation and the natural stone was particularly loose and highly soiled. After the analysis of the building materials, we decided to remove the render and replace the windows. The use of the rooms with laboratories, office and scanning electron microscopes could not be relocated. Effective protective measures had to be taken there. No. Can you take the next picture, please? Okay, we see the room of the electron microscopes and laboratories and offices, and we don't stop the work. We have the people work during the construction workers. The building should be given a minimum thermal insulation. This was an important aspect for later indoor renovation. Therefore, a simple render reconstruction was not possible. Constraint points were the natural stone base and the concrete eaves elements. Can you make the next, please? So, yes. Concrete elements are all the same. And, yeah. So, yeah. Okay, here. This is schwer. It's difficult. This point is important, and we see a variation with a normal insulation. It's not. It's too high, and the other situation. Can you take the next slide, please? Okay, yes, here's better. And here we see the point with, in detail, with traditional insulation. And the last, please. Yes, no, jetzt funktioniert's, okay. And here with Aerogel insulation. And this, this detail, this is an important fact for the working. This was the constraint points for the natural stone base. The clear requirement of the State Office for Monument Preservation was not to exceed the outer edge. Therefore, a traditional insulation was out of question. I show you. Moreover, the clearly structured facade had to match his historical original. And last, for the fire protection, were class A1 without organics elements required. Both the wooden windows and the aluminium windows strips were to retain the historical dimensions, but to include contemporary thermal insulation glazing. You see, we take it also new, the old windows, wood windows, and the wooden windows mounted from had to mount it from the outside without separate special construction like it is required by a normal insulation in a high over. We can mount the windows in a normal wall and not with a separate construction. And this was also important point. And the last point and the biggest wish of the client was it should not more expensive. We were able to solve all problems except for the last point. For the solution of the complex requirements of the thermal insulation and thermal bridges, the monument preservation, the reconstruction of metal windows, the installation of wooden windows from outside, the natural stone renovation, the continuing of all rooms during the construction work, and the use of natural building materials, and so on, was one master key, the use of a high performance insulation render Aerogel Fixed 222. Excuse me. We received a great approval from the scientists of the F.R. Finger Institute, and for our client, the Thuringian Building Authority, we could develop a concept with convinced him. In the end, we were able to meet the construction cost that we determined on this basis. The realization was done very well with the local construction company Döbele, a normal, small, traditional minor render company. Through the complete construction process, we received consistently a very good technical support by the manufacturer Hasid due to their professional competence. I would like to thank you very much. With today's, there are a large number of new products in the construction sector, which often no longer exist after a few years. So it is, of course, a high risk for a smaller architectural office to get involved in a large project with a new building material. But the whole world is spinning faster through science and research than it was 60 years ago. And the tradition of the architects and the users of the F.R. Finger Institute, it was a challenge for us to keep up with the development. And in the end, we even made friends with the yellow color, which proved to be the original shadow and gives the building the attention it deserves. Thank you very much for your attention.
Thank you, Mr. Hoffman, for interesting presentation. And now I welcome here one of our jurors, Mr. and architect Beat Kämpfen, to conclude opinion of the jury on the project.
Gut. Guten Abend, ich repräsentiere hier die Jury. Warum haben wir dieses Projekt ausgezeichnet? Wir haben uns entschieden, 3 Projekte einen Preis zu erteilen. Es gibt nicht einen dritten, zweiten und einen ersten, sondern wir haben 2 zweite Preise verliehen. Entgegen diesen Aerogel-Symbolen hier sind die also 2 gleich groß und eines etwas größer. Dieses Institut an der Bauhaus-Universität hat unserer Meinung nach einen Preis erhalten, weil es die sachliche Moderne der 50er Jahre sehr gut restauriert worden ist. Es ist eine sehr konsequente Außendämmung passiert, die eigentlich keine Wärmebrücken enthält. Und auf der Innenseite konnte ja nichts renoviert werden. Also ganz herzliche Gratulation den Autoren. Wir machen gerade die Preisübergabe, oder? Okay, later. Okay, and then I translate what I said in German before. The jury I'm representing here the jury and the opinions of the different members. We like this project especially because it represents an interesting building periods of the 50s in a very austere modern architecture. And this, it is important that we save these buildings, that we say, because they will be important in future as a period of time. And the renovation here was made very consistently. It is an exterior renovation with aerogel, and there are almost no thermal bridges anymore in this building. So it will get a second prize for this wonderful renovation we liked very much in the jury.
I will ask now Mr. Michal Ledermann to present their project of renovation of Mühlestock in Madiswil here in Switzerland.
Guten Abend miteinander. Ich werde den Vortrag auf Deutsch halten. Verstehen Sie mich? Okay. Besten Dank, herzlichen Dank für die Einladung und dass wir die Möglichkeit haben, heute Abend unser Projekt hier vorzustellen. Funktioniert das? Aha, okay. Mein Name ist Ledermann Michal, bin Architekt aus Langenthal. Zuerst werde ich euch ein paar Worte zum bestehenden Gebäude machen, dann zu den Wünschen der Bauherrschaft und anschließend zu unserer Umsetzung. Beim Objekt handelt es sich um einen Mühlestock aus der zweiten Hälfte des 17. Jahrhunderts. Er ist im Bauinventar der kantonalen Denkmalpflege des Kanton Berns, ist eingestuft als schützenswert, also ein Objekt von kantonaler Bedeutung. Sie sehen hier, geht das nicht? Hoppala, das ist noch schwierig. Ja? Auf der rechten, Sie sehen hier den Beschrieb der kantonalen Denkmalpflege für das Gebäude. Das ist nicht gut. Okay. Also. Hier ein paar Bilder von außen des bestehenden Objekts. Sie sehen hier auf der rechten Seite, das funktioniert doch, die Südfassade des Mühlestocks mit dem Erdgeschoss etwa 4 Meter hoch in Massivbauweise. Auf der rechten Seite befand sich früher das Wasserrad für die Mühle und im ersten Obergeschoss und Dachgeschoss waren die Wohnräume. Links unten die Ansicht aus der Nordwestseite. Man sieht dort auch noch ein Türportal, das aber zugemauert wurde. Das war auch eine Chance für uns, das wieder zu öffnen. Wir haben auch noch eine zweite Öffnung gefunden auf ursprünglichen Plänen. Hier sieht man noch ein Emblem, das befindet sich über dem Türsturz im Erdgeschoss mit dem ersten Umbau von 1884. Hier sehen Sie ein paar Bilder vor dem Umbau aus dem Erdgeschoss, wie bereits gesagt, Massivbauweise, etwa 4 Meter hoch mit einer wunderschönen Decke, mit einer Balkenlage, Patina. Da sieht man noch die Spuren der letzten Jahrhunderte, der Transmissionsriemen, die diese Mühle angetrieben haben, die alles massiv, wo das alles befestigt wurde und daneben die Kammer mit dem Wasserrad. Die Ausgangslage. Nur das erste Auge und das Dachgeschoss waren bis jetzt bewohnbar. Geheizt wurde mit einer Elektrospeicherheizung. Der Raum im EG, das sind etwa 300 Kubikmeter, wurde nur sehr selten genutzt. Aus einem einfachen Grund, er lässt sich sehr schlecht heizen. Ein unangenehmes Raumklima, nur im Hochsommer war es dort angenehm, war es immer kühl. Die Wünsche der Bauherrschaft. Sie wünscht sich eine Totalsanierung aller Geschosse, dass alles bewohnbar wird. Sie wünschen sich ein neues Heizsystem mit erneuerbaren Energie. Und aus dem großen Raum im EG, welchen Sie liebevoll Rittersaal nannten, wollten Sie einen Raum für Wohnen, Essen und Kochen. Die Charakteristik des Raumes im EG sollte so bestehen bleiben, wie es vorher war. Die frei werdende Fläche im ersten Auge, wo ja die Küche bis jetzt war, wird benutzt für ein großzügiges Bad. Zum Sanierungskonzept. Wie bereits gesagt, wir haben ein Bruchsteinmauerwerk, ca. 70 cm dick, das sich nach oben verjüngt. Die Oberflächen sind extrem uneben, gewellt, verformt und zum Teil hat es sichtbare Fensterstürze aus Eiche. In der ursprünglichen Variante planten wir eine Innendämmung mit einer Vorsatzschale, mit einem Holz- oder Metallständer mit Steinwolle, Dampfbremse, Beplankum, Abrieb. Das gab dann jedoch viel zu viele Probleme nach Messung der Feuchtigkeit im bestehenden Mauerwerk. Wir hätten unkontrollierte Hohlräume hinter der Vorsatzschale gehabt. Aufsteigende Feuchte im Bruchsteinmauerwerk wäre nicht kontrollierbar gewesen. Und für mich ganz wichtig, der Raum wäre ehrlich zerstört gewesen, weil eine Vorsatzschale wäre der perfekte Kubus im Raum gewesen mit glatten Oberflächen, viel zu glatt, einfach eine glatte Kiste, das entspricht nicht dem Bild, was wir vorgefunden haben. Aus diesem Grund sind wir deshalb auf die ausgeführte Variante zum Aerogel Innendämmputz gekommen. Es wurde der bestehende Putz entfernt, Zementanwurf, Aerogel Wärmdämmputz, Einbettmörtel mit Glasfasergewebe und dann noch ein Edelputz 1 mm mit dem Schwamm bearbeitet. Vorteile: Die Charakteristik des Raums blieb so komplett erhalten. Bauphysikalisch hatten wir ein offenes System. Die Nachteile ist allen bekannt: höhere Stellungskosten und eine eingeschränkte Befestigungsmöglichkeit für Bilder, aber auch für andere Installationen. Komme ich dann im Sonderfall dazu. Die Faltwerktreppe. Wir mussten eine neue Treppe erstellen vom EG ins ersten OG, haben uns für ein modernes neues Element entschieden, eine Faltwerktreppe. Die konnte jedoch nicht im Bruchsteinmauerwerk befestigt werden. Das war zu wenig stabil. Wir haben uns hier für eine Variante entschieden, dass wir oberhalb der Treppenstufen eine Innendämmung aus Aerogel-Dämmputz haben und die Treppenstufen auf einer Vorsatzschale aufliegen. Das sieht man hier. Also wir haben im unteren Bereich die Vorsatzschale, welche auch die Möglichkeit hat, die ist hinterlüftet, damit aufsteigende Feuchte aus dem Bruchsteinmauerwerk entweichen kann, ist hinterlüftet. Hier ist nicht Außenmauer, sondern hier befand sich das Wasserrad, also nicht ein Raum direkt zum Außenklima. Und dann haben wir hier den Aerogel-Dämmputz. Sie sehen auch die Wand schematisch eingezeichnet, also jede Treppenstufe hatte eine andere Länge und wurde vor Ort eingepasst. Sie sehen dann in der Mitte, der alte Putz wurde bereits entfernt. Etwas bis unterkant von den Treppenstufen wurde der Aerogel-Dämmputz aufgebracht. Beim mittleren Bild sehen Sie die Vorsatzschale als Auflager für die Treppenstufen, Aufsicht von oben und dann ganz links das Bild, wie die Faltwerktreppe montiert wurde. Ausführung sind Sie den Grundriss vom EG, der große Raum. Hier hatten wir die Möglichkeit, einen neuen Windfang zu realisieren unter der Laube, die Küche in der Ecke und dann, wo das Wasserrad früher war, wurde der Technikraum eingerichtet mit einer Wärmepumpe mit Erdsonden. Und hier noch ein Anbau, das war aber dann wieder unter dem Terrain für WC und Redui im EG. Und oben links sehen Sie die Treppe aus unserem Bild. Hier ein paar Eindrücke aus dem Innenraum. Sie sehen die Treppe rechts. Die Stufen wurden mit Schattenfuge ausgebildet an den Aerogel-Dämmputz. Der linken Seite die Wange, die dann statisch wieder die Treppen außen hält, mit dem Handlauf mit Beleuchtung. Im linken Bild sehen Sie die alte Decke, die wurde nur gebürstet und mit Wachs behandelt. Hier sehen Sie ein Detail auf der linken Seite, Anschluss des Aerogel-Dämmputzes an die bestehenden Fensterstürze aus Eiche. Das blieb alles sichtbar. Auf der rechten Seite sehen Sie das Beispiel, wie die Küche sich an die Außenwand anschließt, wie breit das Bruchsteinmauerwerk unten war und dann die Küche konisch angeschlossen wurde. Hier noch ein Bild von der Westseite. Noch einmal ein Bild unter der Treppe. Also eigentlich ist die Wand unter der Treppe die einzige Wand, die wirklich eben ist und glatt. Aber das spürt man gar nicht. Alles andere ist wirklich wellig und erfolgt der Kontur des bestehenden Bruchsteinmauerwerkes. Im ersten Auge hatten wir dann die Möglichkeit, ein großes Badezimmer einzurichten. Seht das auf der linken Seite. Man sieht auch sehr schön, wie das Gebäude über die Jahrhunderte sich in der Mitte gesenkt hat. Also wir hatten etwa 40 cm tiefere Balkenlage in der Mitte des Gebäudes. Auf der rechten Seite der Korridor im ersten Auge. Dann zum Äußeren. Das ist der realisierte Windfang, den wir bewusst als modernes Element unter die Laube gestellt haben. Sieht wieder hier eigentlich die alte Öffnung, die wir freigelegt haben. Und daneben befand sich bereits ein Zugang, der vor etwa 50 Jahren zugemauert wurde. Das ist der neue Hauseingang. Noch im Ansicht die Lamellen, die Dreieckslamellen, die sind immer verdreht, einmal nach außen, nach innen. Und links unten der Effekt, der sich ergibt in der Nacht, wenn dann innen das Licht brennt und durch die Lamellen nur diese einzelnen Lichtschlitze sichtbar sind. Unsere Erfahrungen mit dem Aerogel-Wärmedämmputz. Vorteile. Ein angenehmes Raumklima, das hat man bereits nach ein paar Wochen Trocknungszeit gemerkt. Wir waren mitten im Winter im Umbau. Mit nur einer kleinen Elektroheizung war eigentlich der Erdgeschossraum mit 300 Kubikmeter sofort warm und angenehm. Platzsparend, ein offenes System, bauphysikalisch, und die Oberfläche ist modellierbar. Nachteile, längere Trocknungszeit kann man einplanen, höhere Baukosten, der Untergrund muss tragfähig sein und es braucht Sonderlösungen für Montage von Küchenoberbauten, Spezialtreppen und andere Teile. Rückmeldungen vom Bauherrn, sehr angenehmes Raumklima. Hätten Sie nie gedacht, dass dieser Rittersaal, wie Sie ihn nannten, so angenehm zum Nutzen ist und dass Sie nun endlich keine kalten und unangenehmen Außenwände mehr haben. Bautafel, Bauzeit war November 18 bis Sommer 19, Bauherrschaft Familie Reinmann, Architekturbüro Ledermann AG, vertrete ich. Wir haben mit dem Dämmsystem der Firma Fixit gearbeitet. Und die Gipserarbeiten ausgeführt hat die Firma Klossner aus Burgdorf. Das wär's.
I'll just be summarizing this in English quickly for those who didn't understand. So the presented building conversion realization concerns the former mill in Madiswil in Switzerland. The building from 1844 is classified as worthy of protection by the preservation of historical monuments. The exterior walls of the ground floor are made of 50 to 70 centimeter quarry stone masonry. To preserve the external appearance, the Aerogel Fixit 222 interior insulation plaster was chosen. The presented detail concerns a partition wall to the former engine room, where the water wheel and the machinery were located. This quarry stone wall has many irregularities, and due to the composition, it wasn't possible to fix the new stairs. Instead of doubling the wall, it was decided to emphasize these irregularities. This solution also permits the prevention of potential humidity from the lower area of the wall. The visible area from the wall above the stairs was insulated with aerogel to maintain the irregularities from the wall and to preserve the original characteristics of the room.
Also, die Jury meinte dazu, der kleine Umbau zeigt, dass mit einer detaillierten und feinfühligen Planung sowie dem Einsatz von neuen Materialien historische Bausubstanz respektvoll erneuert und energetisch verbessert werden kann. Ich glaube, jeder von uns möchte gerne in diesem Haus wohnen. Ich glaube, das ist klar. Die Jury sagte, alle sagten, ja, das ist ein wunderbares Haus. Ich möchte da gerade einziehen. The small renovation shows that with the detailed and sensible design and the use of new materials, historical buildings can be respectfully renewed and energetically improved. Every member of the jury and every member here in this room would like to live in this house. I'm very sure about that.
And I will invite now the Mrs. Verna Klar, who will present their project of renovation of multi-family house in Tübingen. Mrs. Verna Klar is an architect, and she made energy efficiency design of the project, and a project of restoration is from civil engineering studio of Gerhard Schmid. Floor is yours.
Thank you. Also ich werde auf Deutsch und Englisch reden und jetzt erstmal mich so rumdrehen, mehr zum Publikum. Kann man mich hören? Gut? Gut. Ich möchte Ihnen nun ein Projekt in der Stadt Tübingen in Baden-Württemberg vorstellen. Tübingen besitzt einen mittelalterlichen Stadtkern, umsäumt von einer klassizistischen und gründerzeitlichen Bebauung. Die Stadt hat neben Heidelberg zudem eine der ältesten Universitäten Deutschlands und wurde als eine Stadt des Wissens und der Denker vom Zweiten Weltkrieg nahezu verschont, während die Nachbarstadt, ein Industriestandort, stark ausgebombt worden ist. Das intakte Stadtbild führte im Jahr 2019 zur Einstufung der Tübinger Altstadt als denkmalgeschützte Gesamtanlage. In diesem sensiblen und historisch wertvollen Umfeld lassen sich Fassaden verständlicherweise nur moderat und mit Augenmaß dämmen. Perhaps some of you know Tübingen, you know it as we know now. A city south of Stuttgart, where the project presented in the following is situated. Its well-preserved medieval city center, surrounded by neoclassical and Wilhelminian buildings, and its university, founded in the 15th century, attract many visitors. Since 2019, Tübingen's Old Town has been listed as a complete monument. In this sensitive and historically valuable environment, facades can understandably only be insulated moderately and with a sense of proportion. In der Straße unterhalb des Schlosses, der am Fluss gelegenen Neckarhalde, wohnten im 19. Jahrhundert gut ein Dutzend Professoren mit ihren Familien in herrschaftlichen Häusern. So auch in der Neckarhalde 32, welche im Jahr 1829 von einem Juristen und Privatgelehrten als Wohnhaus erbaut wurde. Das Gebäude steht heute mitsamt der terrassierten Gartenanlage unter Denkmalschutz. In the Neckarhalde street below the castle, situated on the river, a good dozen professors and their families lived in stately houses in the 19th century. House number 32 was built in 1829 as a residence for a renowned lawyer and a private scholar. At that time, Tübingen had about 8,600 inhabitants. Today, there are 10 times as many. The building and its terraced garden are listed monuments. In der Folge ein Auszug aus der Begründung der Denkmaleigenschaft. Das breit gelagerte Haus ist bezeichnend für die ersten Wohnbauten, die im frühen 19. Jahrhundert unmittelbar vor den Wällen der alten Städte in offener Bauweise zumeist an neuen und attraktiven Straßen und vor einem großen Gartengrundstück entstanden. Gestalterisch wirkt es vor allem durch den axialsymmetrischen Aufbau mit seinem bis zum Gurtgesims hinaufreichenden Mitteleingang. Ja. Dem beherrschenden Dachhaus an der Straßenfassade sowie durch die Ausstattung aller Fenster mit Klappläden. In the following, an excerpt from the justification of the monument status. The broad-based house is characteristic of the first residential buildings that were built in the early 19th century, immediately in front of the ramparts of the old cities in open construction, mostly on new and attractive streets and in front of a large garden plot, and so on. (1931) wurde das Haus von der Kirche erworben und innen derart umgebaut, dass auch größere Veranstaltungsräume entstanden sind. Die äußere Erscheinung blieb jedoch größtenteils unverändert. Lediglich ein neuer grober Kammputz wurde auf die Hauptfassaden aufgezogen. Als das Gebäude im Jahre 2017 abermals den Besitzer wechselte, und der steht hier mir gegenüber, Herr Haufler, sollte es unter Wahrung seiner Anmutung und Proportion wieder der ursprünglichen Nutzung, dem Wohnen, zugeführt werden. The exterior of the house remained largely unchanged. Even when it was acquired by the church in 1931 and generously rebuilt inside. At that time, the plaster on the facades was completely removed and replaced by a comp plaster. When the building changed hands again in 2017, it was to be returned to its original residential use while preserving its appearance and proportions. 8 residential units with 620 square meters of living space can be found in it. A restorer first examined the sequences of layers on the facade plaster and its various color finishes. The plaster from 1931 was defective and in need of renewal. A thickness of 4 centimeters was available because the historic formative facade elements were to be preserved. You see in the left photo. On the basis of an overall energy balance, different variants were examined. Interior insulation, various thermal insulation plasters, including the Aerogel plaster with its very good insulation values. The client himself, he was quickly convinced by the material. The monument authority, on the other hand, was skeptical at first, not wanting any experiments, but was finally won over to the use of the modern material by built examples in Switzerland. Die Schichtenfolge des Fassadenputzes und seine diversen Farbfassungen wurden zunächst von einer Restauratorin freigelegt. Der Putz von 1931 war schadhaft und erneuerungsbedürftig. Unter Erhalt der historischen, gestaltprägenden Fassadenelemente, zum Beispiel Gurtgesimse, stand eine Dicke von 4 Zentimetern zur Verfügung und das sehen Sie unten auf dem Foto links. Innendämmungen wurden wegen Befunden auf der Innenseite schnell ausgeschlossen. Mittels einer energetischen Gesamtbilanzierung ließen sich verschiedene Wärmedämmputze an der Fassade, darunter auch der Aerogel-Putz mit seinen sehr guten Dämmwerten, miteinander vergleichen. Die Bauherrschaft war schnell überzeugt von dem neuen Material. Die Denkmalbehörde hingegen zeigte sich zunächst skeptisch, da Aerogel in Deutschland noch nicht so bekannt war und es eigentlich nach wie vor noch nicht so ist. Sie wollte vor allem keine Experimente. Schlussendlich konnte sie doch für den Einsatz des Materials gewonnen werden, da es viele Vorteile bietet und eben hier in der Schweiz bereits gut erprobt war. Den Übergang vom Erdgeschoss aus Sandstein zum Obergeschoss aus verputztem Fachwerk sehen Sie auf diesem Detail. An bestehende Verblechungen, an die Holzfensterleibung und die profilierten Gurtgesimse galt es anzuarbeiten. Die einzelnen Bestandteile des Aerogelputzes wie Silikat und Kalk reihen sich gut in die im Denkmal typischen Materialien ein. The transition from the ground floor made of sandstone to the upper floor made of blasted half timbering can be seen in this detail. Existing sheeting, wooden window reveals and profiled cornices had to be worked on. The individual components of the aerogel blaster, such as silicate and lime, fit in well with the typical materials used in the monument. Der Altputz wurde zunächst komplett abgeschlagen. Auf das Fachwerk brachten die Stuckateure Balkenpapier auf, versahen die Fassaden mit einem wellenförmig gebogenen Putzträger, spritzten hierauf zunächst eine Haftbrücke und dann den Aerogelputz. Die Handwerkerschaft mochte das Material, das sie erstmalig verarbeitete. Es ist leicht, lässt sich gut abziehen, passt sich Unregelmäßigkeiten im Untergrund an. The old blaster was first completely knocked off. On the framework, the blaster supplied beam paper, provided the facades with a wave-shaped bent blaster base, sprayed on this first the bonding bridge, and then the aerogel blaster. The craftsmen loved the materials, which they used for the first time. It is light, easy to handle, and adapts to irregularities in the ground. Die Farbgebung des neuen Fassadenanstrichs, der Holzgesimse und der Klappläden basiert auf den Befunden der restauratorischen Untersuchung. Auf dem Foto sehen Sie die freigelegte Schichtenfolge der verschiedenen Farbaufträge an den Klappläden. Die Holzläden stammen noch aus der Bauzeit und sind somit über 190 Jahre alt. The color scheme of the new facade paint, the wooden cornices and the hinged shutters is based on the findings of the restoration survey. The photo shows the exposed sequence of layers of the various paint applications on the folding shutters. The wooden shutters date back to the construction period and are thus more than 190 years old. Nun erscheint das Wohnhaus aus der Biedermeierzeit in einer farblich stimmigen Anmutung, elegant und wie ich finde zeitlos. Now the residential house from the Biedermeier period appears in a color-coordinated grace, elegant and, in my opinion, timeless. Zum Schluss noch ein paar Worte zum Thema Energie. Zusammen mit anderen energetischen Maßnahmen an allen Bauteilen erreichte das sanierte Gebäude den sogenannten KfW-Energieeffizienzhausstandard Denkmal und erhielt so Bundesfördermittel in Form von Zuschüssen. Darüber hinaus erfüllt es auch die Vorgaben der Energieeinsparverordnung für Sanierungen. Eine Pelletheizung mit 2 großen Zack-Silos im Gewölbekeller sorgt für eine sehr gute CO2-Bilanz. In terms of energy, the renovated building performs quite well for the listed building category. Thanks to insulation measures on the remaining building components and the central pellet boiler, it was possible to drastically reduce the primary energy requirement and to receive federal funding. In addition, the new residents can live there with a good conscience and a small carbon footprint. Thank you.
Also, die Hauptworte der Jury sind: Das Projekt ist ganzheitlich, ökologisch und nachhaltig gedacht und umgesetzt. Materialien wurden möglichst weiterverwendet. Die Eingriffe sind sehr behutsam ausgeführt und sinnvoll aufeinander abgestimmt. Die Volumetrie blieb erhalten und der architektonische Ausdruck konnte geklärt werden. Die energetische Erneuerung ist mustergültig. And in English, the project is designed and implemented in a holistic, ecological and sustainable manner. Materials are reused as far as possible. The different interventions are carried out very carefully and sensibly coordinated. The volume is preserved and the architectural expression is even clarified. The energetic renewal is exemplary.
Thank you very much for interesting presentations. And now I think we can step to handling. I will ask again Mr. Kämpfen on the stage and yeah, to handle and announce the winners.
Yes. Ich möchte zuerst noch den Veranstaltern danken, dass sie einen Aerogel-Wettbewerb ausgeschrieben haben. Ich glaube, es ist sehr wichtig, dass man dieses Material propagiert, unter die Leute bringt. Die Referenten haben es schon gesagt. Das Material ist noch weitgehend unbekannt. I would like to thank you, the Empa and Michal, Samuel, to provide us with this aerogel competition. I think it's a very important thing to communicate the advantages of this material and to bring it to the different countries. Mein erstes Haus als junger Architekt, 1983 gebaut, isolierte ich mit 12 Zentimetern Dämmwolle, Steinwolle. Und ich hatte einen älteren, erfahrenen Bauleiter und der sagte mir, Beat, du spinnst. Man kann auch zu viel isolieren. Seine Bauten hatten so 4 Zentimeter Isolation, oder? So my first house in 1983, I insulated with 12 centimeters of rock wool. And I had an older construction manager for this house, as I lacked experience. And so he told me, Beat, you're crazy. 12 centimeter is too much. This doesn't make any sense. It's unhealthy and so on. His houses in the 1980s were insulated with 4 centimeters of rock wool or glass wool or whatever. Since these insulations got bigger and bigger and bigger, nowadays laws are requiring, I would say, 24 centimeters of insulation. My buildings, since probably 20 years, are insulated with 36 or 40 centimeters of insulation of rock wool. And of course, this is terrible for all architects. Ich habe es umgekehrt gemacht. Unterdessen verlangen die Gesetze viel stärkere Isolationen. Sie verlangen 20 Zentimeter bestimmt. Sie verlangen bis 24 Zentimeter. Meine Gebäude sind seit jetzt etwa 20 Jahren mit 30 bis 40 Zentimeter isoliert. Also es sind ganz andere Dimensionen in einer sehr kurzen Zeitspanne passiert. Alle Architekten hassen das. Alle Architekten wollen schöne, schlanke Fassaden und wir werden gezwungen, aus gesetzlichen, aber auch aus energetischen Gründen, dicke Fassaden zu machen. Und so, glaube ich, ist es extrem wichtig, dass die Industrie uns jetzt wieder hilft, in diese Isolationsstärken zu reduzieren. Und da leistet Aerogel ein ganz wichtiger Beitrag. All architects hate these thick insulations because it's terrible. Architects like to have small or slender facades. slender constructions, but we are forced by laws and by energetical evaluations to make all these thick facades. And so I think it's very important that industry, that producers help us to reduce again the thickness of the insulations. And therefore, I would like to thank Michal again, Samuel, and all others, all other scientists, to go ahead and to help us and to bring us new products on the market that we can implement on our buildings. Also, vielen Dank euch allen, den Wissenschaftlern und den Forschern, dass ihr so schöne Dinge macht. Wie schon gesagt, es gibt 2 zweite Preise. You can give it. 2 zweite Preise. Wir beginnen mit dem. Es sind etwas unterschiedlich. Es ist ein Aerogel-Symbol. Ich denke, dass den zweiten Preis hier kriegt die Bauhaus-Renovation. So we have 2 second prizes for these wonderful renovations. Yes. And it goes to the Bauhaus. We shouldn't do that. Okay. Then we have another second prize, and this second prize is for this very holistic renovation in Tübingen. Then, ich sagte es bereits, wir alle möchten in dieser wunderbaren Mühle in Madiswil, irgendwo im Kanton Bern, wohnen. Es sieht dort wirklich sehr romantisch und sehr schön aus. Und deshalb hat diese Mühle den ersten Preis gewonnen. The first prize goes to this Mühle in Madiswil. It's a little village somewhere near Bern. And everybody would like to live there, and so the jury was very much impressed by the diligence of the planner.
Congratulations again to winners and speakers, and we will have photos, maybe one by one here, but probably only winner can be mask off. Because of the rules. And then we will continue with our tour, and we will have also common photo outside everybody. So I would like to thank you again to everybody who somehow contributed to this, also to our partners, Fixit, Agitech, Advapor, Hasit, and Haga. Thank you very much for support. And I'm going to translate maybe.
Auch auf Deutsch möchte ich gerne meinen Dank ausdrücken für die Ermöglichung durch die Sponsoren, durch Fixit, durch Agitech, durch den Verband Advapor, durch die Firma Haga und durch Hasit, die Schwesterfirma von Fixit.
Yeah. Thanks again, and we are looking forward for the next edition of the Aerogel Architecture Award. And I will just tell that we will make a common photo with masks, everybody here, with the winners, and then we will repeat the photo outside. Yeah. So thank you very much. And after this, we can join our guided tour through the nest. We will see units where Aerogel is used, and then everybody is welcome to join Apero.
Machen wir mal die Preisträger in die Mitte, oder?